Good morning also from me. Let me share my screen. There we are. You should see a screen. If not, holler, please. Right, I want to look into live coding some microservice integration patterns. And a fun fact, as you can see, I don't have the best light. I don't have the best camera at the moment. So I'm kind of got stuck with my train late evening. So I'm at a different place as I should be and don't have the right equipment. But we're talking a lot about failure getting normal and complex systems, and resilience is everything. So I think that's a good setting for today's talk. So welcome, and let's take it away. I actually have a starting story around traveling, so that also fits everything well, I guess. Normally, if I'm in a live setting, that's a good point, and can ask people like, who has used an airplane before? I can't see your hands actually, but you can do the exercise in your head. And probably you did, right? And if you book a flight, the normal procedure is that before you can board the train, you actually have to check in the aircraft, right? And this you normally do 24 hours before. Procedures might slightly differ, but that's still the most typical thing. And then you get a kind of an email invitation. You have to click through a couple of pages and you want to check it. And at the end, you get the boarding pass, which you need at the airport to get to your gate, right? Relatively simple and straightforward. I did that for a flight. It was quite a while back, but I still like the story a lot, actually. And that was with Eurowings from Stuttgart to London. And when I was checking in, at some point in time, it basically gave me that message, right? There was an error sending you a boarding pass. Okay, you probably had that before. When I talk to people, most people also know that kind of issue you normally have. What would you do? Again, you can't scream in the room, so I assume you would probably do. The normal thing is you retry it, right? You do it again. Okay, that didn't work. Let's try it again. It didn't work. What's the next thing? You wait a couple of minutes, right? I mean, we're computer scientists. We studied that thing probably. So we know we should probably wait for it to resolve from like magically by time. I did do that. I tried it 5 minutes later, which still didn't work. So I assumed they had some kind of severe problem somewhere. And what I did next is I actually made a calendar entry on my Outlook calendar to think about retrying it a couple of hours later, right? And this is a very interesting actually story to dissect from also from an integration perspective. So the way I assume it is like, okay, I'm basically in front of a web UI. I wanted to check in. It probably uses some kind of check-in, let's say service or microservice or functionality, whatever terminology you want to use in your organization. So you have that check-in microservice, and that probably needs other services to work, right? So for example, and that's my the assumption I do for that talk, there's a barcode generator to do that 3D thing you need for getting to the gate, probably a PDF generator. I think British Airways can still send you the boarding pass as a fax. So there are probably a couple of components you need in order to get that going. And one of those was not working. So let's assume the barcode generation doesn't work, which might happen. And that's exactly what I said in the very beginning. The bigger systems we have, and we do bigger and bigger systems by the day, composed out of more and more components, the more normal it gets that some parts are broken. It's kind of the reality. Something is always broken. And like 20 years back, we sometimes try to avoid that. We try to make really highly available systems, and nothing is never broken. But that's an assumption that's not holdable anymore. So something is always broken, but we have to make sure this doesn't affect like the whole system. So failure is there, but we have to accept it. We have to avoid that this will really get your whatever whole system down. It should be kept local, and probably then some small functionality is not working, and you might fall back to some plan B, for example. So avoid the big fire, right? If we go back to that example, what basically the design of that page did back then, at least, the problem in the barcode generation was basically like really rethrown all the chain up to me as a user, sitting in front of the web UI. And it basically was made my problem, which I think is a really, really bad design. Then I had to do the retry, and even this, what I call a stateful retry, like putting in my Outlook calendar to not forget checking in again, which is something software could do for me, right? That's nothing I should be put into, required to be doing. And at the same time, we will discuss that a little bit later as well. At the same time, very often requirements, a lot of companies still look into this kind of functionality in a way that it has to be synchronous. People are in the web, they want to see the boarding pass right away. It has to be a synchronous response, which I also find not true. I mean, I want to have a boarding pass, not an error message. So if the boarding pass comes to my app via email or whatever, before the flight, that's fine. I don't need it right away. So that's also come back to that later on, and a very important line of thought from my perspective. Okay, so we want to actually get rid of that design. Fun fact, and it's true, I promise that's true. It was my onwards flight from London with EasyJet this time, and they had exactly the same problem. So, but that was interesting because they give me the work instructions according, like together with the error message. We're having some technical difficulties. Yeah, it can happen. Please log on again, retry. If that doesn't work, please try again in 5 minutes. Oh, increase the retry interval. We do actively monitor our site. We'll be working to resolve the issue. There's no need to call. Leave us alone. Go solve it yourself, right? And this is, I mean, yeah, if I look at that and if I make fun of it, it's probably very provocative, but it's kind of the mentality I see also within organizations often when looking at different teams that are providing different, for example, microservices and consuming other microservices. This is kind of the mentality we very often see. And I find that a big problem. And it leads to a very badly designed system and architecture. So it should be more like, hey, we have some technical difficulties. That's on us, our problem. We take care of it. We solve it. Right. Okay. How could we do that much better in this example, in that easy example? I mean, the check-in components wants to talk to the barcode generator, and it should take care of that if it's not working. It should do the stateful retry. It should not be delegated to me. And then you have a much more local scope where you can solve that. We will look into messaging a little bit later. So couldn't I just solve it on the transport layer? That's something we also look into in a minute. Okay. So that's actually a much better design, right? No, I don't have to care. And again, all right. And the reason why I see a lot of teams not doing that, it sounds easy, right, on a slide, just do the stateful retry and the check-in component. The reason why people are not doing it very often is because they don't want to have state in their services. We all know that like stateless services are much easier to implement, much easier to operate, much easier to everything. So we want to have them stateless. Because otherwise I have to keep state, like a database or whatever. As soon as I keep state, I need to have a lot of like management around that. Like I probably want to see what's currently still waiting for generating a boarding pass. I probably need some escalation mechanism if that's not happening on time, and so on and so forth. So that's a lot of complexity that's added. And if you're going in there like accidentally, it might be what's called accidental complexity. Oh, we just wanted to do a retry, and we might need to wait for a couple of hours. And now we have the database table, that scheduler, that thing over there, and this and that. Yeah, that's a bad place to be. I agree. So it's a challenge you have to solve. And the other one that's less a technical challenge for me, it's more also get business requirements or the business on board in a way. Now we are getting more and more asynchronous in the way we communicate. So that means I might not get the boarding pass right away. So we should probably let go of that belief that we need synchronous blocking responses for everything. It's okay. People are totally used to that. I don't want to print out the boarding pass when I generate it. I have it on the app. If it arrives in the app on time, it's fine. It doesn't have to be right now. And that relaxes a lot of requirements how we can build systems. And I will go into that a little bit as well. Cool. So that's kind of the framing for the whole talk. I hope that works well with you and that fits your expectations. It's not so much about the direct enterprise integration patterns book, for example. So that's kind of the topics I want to focus on. And as always, I'm a human being. I have my opinions. I have my background. I want to make it transparent. I wrote a couple of books. It's all about process orchestration and workflow engines and these kind of things. So that's kind of, if you want to say so, my bias, or more positive, my enthusiasm. So I'm all into workflow engines. There's my contact details. So if you have any questions, even after the talk, don't hesitate to reach out. Right, and I co-founded Camuna. We're an open source process orchestration platform. So that also kind of, you should have that in the back of your mind. But it's a great platform. So, and if you look at it, for example, a workflow engine can do that. And we see more and more orchestrators, also microservice orchestrators, entering the market, like Camuna being one of them, but there are others, which start to solve these problems, because with exactly microservices, we start to have more and more components that need to be integrated, and we start to have more and more of these challenges we need to solve, right? And that's why, and most of them are long running, because you never know when the system comes up again. And the more, and as I said before, the more long running you can do, the better design of your systems you get. So you could use a workflow engine, process orchestration engine, for doing that. So for example, for check-in, you might just have probably 2 steps, but now you have a workflow behind that where you can say, this can be retried even for a longer period of time. And we look into how that works in a minute. A workflow engine can persist that, can wait for it, has all that management capabilities around that. And it's a great thing actually to use. And I already talked about that. And the customer doesn't want a synchronous response. Let's go into coding. I promised some live coding, and I probably do not even do enough of that, but I hint you to a lot of more code. But I do a little bit of live coding here as well. And I want to use a very easy example where I have 2 services, both Java, both Spring Boot, very simple. The code is available on GitHub. One basically simulates a credit card taking service, and the other one a payment service. And the payment service charges the credit card. Relatively simple thing. We can play around with that a little bit. Right, Java Spring Boot. And there's the code. So if you wanna check that out, I mean, the slides will be available later on as well, but I can make sure to drop the link in the chat later as well. So I have this open. Where is it? There we are. So if I open that project, what I have is I have a couple of different scenarios basically running, and the internet probably had a hiccup in between, but I hope it's back online. I have my credit card service here, and now what I do is don't take that as best practices code probably, but I make a very easy REST controller where I can do payments, and then what I do is I charge the credit card, and the credit card charge is just using a REST template to do a post. I can't ask again who does it like that, who did it like that. I mean, there are different ways now to do that in Spring, I know, but it's still a very, very common thing that I see being used. But as you can see, very, very easy code. So, and actually also pretty boring. But what I can do now, if I'm running that, I can do a put on my payment URL. What it does in the background, it charges my credit card, right? You could probably see that. Gets back a response, everything's fine. Hooray. Probably not a big surprise. What I can do now is I can, actually, I could switch that service off. Probably not that interesting, but let's do that for a second. What happens if I switch it off? We do a synchronous call chain, so obviously now we get an exception, right? Because we can't charge the credit card, so we can't put the payment online, right? Probably not the best experience for the client services already, because that delegates the exception up the chain. The other thing we can do with that small little service is we can make it to behave slow. I'm not going into that too much, but what happens here now, obvious, I hope, the response gets slow, right? Because we now wait for, in this case, 5 seconds, so that's added latency, and this call is blocking. Why is that so bad? Now, if this behaves slow, it means that all the threads running in my payment service are blocked waiting for credit card checks, and at some point in time also payment gets unresponsive. That's a bad place to be. If you're familiar with the typical patterns, you might know a circuit breaker. If not, I make it a homework to look into that. There's the version 2, which uses a circuit breaker. And the circuit breaker is kind of like the circuit breaker in your house. If something is weird with electricity, it switches off to avoid the whole house burning down. And that's the same here. So if the service is not available, or if it's responding too slow, you can configure all of that. There's a lot of configuration, which we don't look into detail at the moment. If it's too slow, it's not even calling the service anymore. And then after a couple of times or a couple of seconds, it retries if the service becomes available again. And that makes the payment service more robust to those slow upstream services. So if I go to my version 2, it behaves differently. The service here is still slow, but if I call it, what you can see is the first one is still taking the whole 5 seconds, which seem long if I'm talking here. But now the circuit breaker actually switched, and we can see the next calls are pretty fast. Okay, I have a 5 seconds interval to be quick in the demo. So this one is, but now the next ones are really fast in failing because the circuit breaker basically says, okay, it's not working, right? And I'm not calling it anymore. So that's kind of an improvement, right? So now we avoid both burning, but it's still that if the credit card service is not available, the client of the payment service has to deal with that. And we want to get rid of that. So the next version is my version 3. And there I'm using a workflow for solving that. In my case, it's DPMN. So you could, I'm not showing that too much today, but you could model these kind of workflows also graphically. But what I used for the simple demo here is I created programmatically. So I basically say, okay, I want to have a BPMN is an ISO standard to define these kind of flows. I want to have an executable process that starts here. Then the only thing it does, it basically calls a Stripe, my service task, the service, my credit card service. And this is connected to some code which is defined here. I'm not sure if you can see that. It's the same type name. So this is a connection between the workflow model and the code that's called. And I now can define retries, how long it should retry, and so on and so forth. And then I deploy that process. And when I charge my credit card, where is it here? I charge my credit card. I no longer do that directly. But what I do is I kick off a new process instance or workflow instance here. And this one then does the service, the credit card charting. I hope that still got clear. So now if I go to V3, it behaves different again. And that's actually interesting. The first thing is that now I kick off a process instance. I get back a response immediately. But with a different HTTP code. It doesn't say HTTP 200 anymore, like, hey, you're done. It says HTTP 202, which is accepted. I got the request. I give you the result later on, which is exactly what I said earlier on, that we might not do it right away synchronously blocking. That's a pattern we should get more familiar with. In the background, what's happened is that we could look at that in the console, but we can also look at that here. Where's my browser? Is that the right browser? Probably not. Go away soon. Oh, it is. There you have tools, for example, to look into what's going on in your workflow engine. So what you can see is I have that one instance, which we just pushed through Stripe. So you get a lot of like audit data, like how long did that take? When did it walk through? What's the data attached and these kind of things. And you could also, if Stripe's not working, you could stay there, retrying, escalating, probably raise incidents later on, do that for hours, add a timer if that takes too long, do something else, call the customer, whatever. So there are now a lot of opportunities actually to improve the long-running behavior here. Cool. I want to quickly, because I'm quite limited in time, I show one example I wanted to show later right now, because I think it makes sense. We're warm with code in our heads. Now the behavior is that we have that 202 accepted, right, all the time. But still, people very often want to have a blocking result for certain services, like returns. And if we assume that most of the time our services behave normal, I'm not even sure if that's true.
Hörst du eigentlich das Gespräch im Hintergrund? Warte mal.
No, we have somebody else talking. I don't hear any other talk in the background. No. Yeah. I hope you can still hear me. That's the most important thing.
Vielleicht das Noise-Canceling besser.
If this service is normal, which should be the case very often, we can switch to a behavior where we say, and now I have to check it.
Ich bin ja bei so einer Java-Konferenz, hatte ich mich angemeldet, online.
Somebody is not on mute.
Nee, eigentlich nicht. Also ich muss eigentlich arbeiten noch weiter, aber ich höre mir das neben.
Okay, I'm muted. So, we're back with, I think it's version 4 then. Right, so version 4 does change the behavior a little bit. So what happens if I go with version 4? What you can see is that I get a 200 completed, everything is fine. Okay, what's the matter now? If I go for slow, what happens if I fall back to a 202? And I think that's a pattern, that's a behavior which is actually very powerful, saying like, okay, we can try to get you a synchronous response, like a blocking result, but it's a best effort. It might happen, but it might not be possible at the moment. So then you should be able to handle also like a async response here. And then we go back to a 202. If you're interested in how that's implemented, the code is on GitHub, so just check it out. It's not very complicated, actually. So what I'm always trying to get at with that is that just because you use technology for long-running things doesn't mean you're forced to do async. But you should always think about that it might be necessary. Okay, good. Let's move on here. So what we use now, we use the workflow engine or orchestration engine, process engine. It's kind of a state machine. So we see a lot of different wordings floating around out there, but it's most of the time more or less the same thing. Now we use that within our microservice. It's stateful, so it can wait for there, can wait there. One quick thing, because I find that discussion very often at the moment. So do we always have to program those integrations? This is the whole pro code versus low code discussion, which gets heated up quite a bit, I would say, recently. And especially developers or Java developers typically don't have a very high opinion about low code, which I can totally understand. The one thing which is interesting to look at is that a lot of integrations, if you look at technologies, typical base technologies, REST, Kafka, messaging, but also certain systems, might it be your normal backend system you use for everything, or might it be the typical SaaS system you have to integrate with? These kind of systems are not super challenging to integrate very often. You have to do that all over and over again. So there is an opportunity to make that simpler with using certain what's often called connectors. At least that's also how we call that. I don't want to go into that too much here, but you can imagine it like this, right? I'm not attaching code now, but I could say, okay, your REST call, and then I directly configure REST here, or your Kafka, and so on and so forth. The important thing I find is that this, in the end, then you have a lot of out-of-box stuff, of course. But the important thing is that for me, this is not something that forces you, especially as a developer, to use connectors. It's more kind of we use this video often to illustrate that. You can tune that in. If you have problems that are simple to integrate, it might be easier, even for developers or for developers to use connectors, or it might enable other roles to do that. So you might not need the JavaPro in order to do that. But if not, hey, you can code it. That's totally fine. It's kind of an offer. If you look at that technology-wise, for example, in Camunda, connector is just as the code we saw early on in Java, plus a bit of what we call the element template, which basically is this bit of property panel for the modeling component. So it's just code, but you can make it graphically configurable and then probably reusable or not, right? So that's kind of an offer, and it's actually pretty powerful. If we look back at architecture, what we did so far, we basically created a solution, Java, Maven, Spring Boot. We had a bit of custom code to call our REST service. And we used, in this case, Camunda. I used the SaaS edition, so it's just a cloud service. And now you could also move certain custom code to integrate to what's from us called a connector runtime. So then it's doing all the integration code. We have somebody not muted again, but I'm quick in muting people now. So there we go. Right. Cool. And the one important thing, and I find this really interesting, is that we know protocol connectors, they always involve code anyway. So for example, REST, Kafka, messaging, typical protocol connector. But we also know certain system adapters that just use a protocol underneath. So for example, Twilio, if you want to send an SMS via Twilio, it's just the REST API. So you could do that with Java code, you could do it with a REST connector, but you could also build, or there is a Twilio connector that basically just configures the REST connector properly. And then, but if you think through that, that's also already more powerful, because now you don't have to understand all the bits and pieces of the Twilio API. But you might want to push that abstraction further and saying, okay, we don't want to use Twilio, we want to send an SMS. So we could do something like an SMS connector, which underneath uses Twilio, which basically is a proper REST call. But the person that defines the integration logic within the process doesn't have to know about that. And this gives you a lot of freedom to play with the different options. If you do certain core processes and you want to have everything automate, if you want to use JUnit to automated testing, you can do that. Then you probably don't want to use all of that or any of that. But you can also add more abstractions to make integration code actually easier. Because, and I find that so important, we see a lot of different integration problems being solved out there with different criticality. As I said early on, systems get more complex. Most companies need to automate really a lot internally and more every day. And not all of those automations, they all involve integrating systems, but not all of them are really complex or critical. If they're not working, hey, so what? But it's better to automate them than not. And this is where very often business departments use certain shaky low-code solutions, because I would say we as developers can't deliver because there are just not enough of us in the organization. So we typically concentrate on the complex ones, but the long tail of simple ones are simply not tackled. And this is why a lot of very often really shaky low-code tools are used there. And I find it much more important, much more interesting actually to make pro-code tools for integration more accessible to also these use cases. And that's kind of the strategy we're driving. And that allows also core developers to enable other roles to help with in defining the integration logic, basically, not on a technical level, but on the what should happen in what order, how long could we retry, is it okay to send the boarding pass 4 hours before the flight, 2 hours, what's the limit here, what should we do if we can't send it, if we can't generate it, should we call the customer, who does that, and these kinds, that's part of integration logic. Right. Back to integration logic. So we do retries, right? We talked about retrying. One important thing I want to add here, and it's surprisingly often forgotten. If you do retries, of course, there's one really important thing, which is idempotency on the other side. What's idempotency? In simple terms, idempotency means you can call the same service twice. You can do the retry without harming anything, right? So, for example, if I charge the credit card, I could have an API which says charge this amount to that card, which is hard to make idempotent because if I retry and have the same charge twice, the credit card service can't really know if that's just I really do the same charge twice. I mean, we have micropayments. Maybe I just watched another movie for exactly the same amount on my credit card, or I bought it at the same time or whatever. So that might be okay. It can't judge that. But as soon as you start to have a transaction ID, which you generate early in the chain, very often these transaction IDs are generated by the client already and passed along the chain, then it can very easily recognize duplicates here, and then it can make a service much easier idempotent. I'm sorry. And this is super important actually to keep in mind. And this is very often one of the hardest part actually when you integrate legacy systems, because they have APIs that really didn't look for idempotency back then. And that's really hard to cover. Then you very often have a facade in front of them, probably doing things like doing a query, looking into the system. Did we do that already? Or making some hashes of messages or whatever. There's certain tricks you might want to do, but very often it's just it's still guesswork, but hopefully good guesswork. Right, let's switch that for a second. Because, and for me, that's a so simple thought, but it struck me when I first had it. I find that super important. So when let's assume you want to charge the credit card from the payment service, you get an exception, network exception. You retry it a couple of times, it doesn't work. And then you decide to give up and say, okay, the payment has failed. Now, you have a distributed systems here. You have the network in between. That's the metaphor for distributed systems. This is your microservice, cozy, probably with the heating, nice and clean to be in there, but you open the door and you face the network, and that's the rough ocean. And that means you might have just lost bits, whatever. And the important thing is you can't really know if you get a network exception, which of those three situations you just faced. So it might be that the request never reached the service provider because the network was broken. It might be you reached the service provider, but it exploded while doing your request. Or the service provider processed everything perfectly, but the response got lost. And that can happen with messaging as well as with REST calls. That doesn't matter. So you don't know. And that also means, for example, in this scenario where I give up to charge the credit card, I might have actually charged the credit card without knowing. It might be a rare example, and there might be a lot of business use cases where you can ignore that problem or let it happen and solve it afterwards. There are strategies around that as well. But first of all, you should be aware that this is a possibility, and it's kind of a business decision if that's tolerable or not. Okay. And for example, you might have to clean it up. You might have to say, okay, if it's failed, I have to try to cancel the charge, which then will inform me if it was charged or not, or I have to query if the charge was done or not. If we have messaging and messaging can overtake them, like timing-wise, some systems have problems with that. I might even want to wait for a little bit, like a minute or an hour before I clean up or whatever. So it's not always super simple. And it's important to have these edge cases in mind. It's always okay to consciously ignore them, saying like, okay, that's an edge case. It's not very often. If it happens, let's solve it then on a case-by-case basis. Fine. But you have to make that decision. And that's what I miss in a lot of scenarios. It's just people don't even think about that this is an important scenario. By the way, typical question is like, okay, but now if the cancel charge, you also have to retry that. And if that doesn't work, what do you do? At some point in time, normally you don't model that anymore. You just let it fail. If that's a workflow engine, if that's Camunda, for example, it creates a so-called incident. You see that in the operating tool. There's a red light. Some operator probably even get notified, depends on what you want to do, and can really dive into that and resolve it manually. At some point in time, you have to give up. Otherwise, you get a model that doesn't make sense anymore. And that's the code I showed earlier on already. And I find it important to embrace asynchronicity here as well. So I can't make show of hands here easily, but typically what I see is between 60 to 80% of the people have REST in most places in their architecture, or probably even SOAP, some of them, but REST is kind of the most common one. And then what they also have is that thinking of, I do a REST call, it looks so simple, I always make it blocking, I get a response right away, and that's my world. And I find it important to think beyond that, to think of, okay, there might be failure scenarios that are long running, that take some time, because that makes my whole design of the overall architecture much more robust. Because if this cannot be long running and the credit card service is not available, the only way what I can do is rethrow the exception. But if I can handle it long running, that gives me a much cleaner API, right? And that's beneficial for my architecture. But therefore, I have to be ready to do an HTTP 202 here. Okay. Don't get me too excited about that. So there are a couple of catch-up slides on exactly what I just saw. Like long running, so that's what I really believe in. Long running capabilities are essential to design good service boundaries, right? To handle the problem within the right service boundary, it very often has to be long running. Good. And that's the example I just said. Like if I retrieve payment, credit card fails, it's a different example, but let's assume it fails. If payment can't do anything about it, it just like passes on the problem. And now think of even like new business requirements. For example, this is not the credit card service is not available, but probably the credit card is rejected. You have a kind of an abo service where the abo is renewed with a credit card that's on your account and the credit card expired, for example. If you have a payment service that can't handle that, it means that in this case, probably the abo service or the order service needs to handle that, the rejected credit card. But it would be a much cleaner design to put that responsibility within the payment service because it's about payment, right? And that avoids that the other services get huge, because that's a situation we see very often. Otherwise, we have that one service that has long-running capabilities, very often the end-to-end services like order fulfillment. And that sucks in all the logic because payment is not long-running. So it's much better to balance that out. Okay. I think I stressed that quite a bit. Good. One last thing I want to talk about in 5 minutes. I make it quick, but we talked about the customer experience. So the customer journey in a way, not expecting synchronous responses all the time in a way, is essential to go into all these kind of modern architectures. So you can make both examples. So for example, Rabbit and Kafka, if I say hipster, I think I have to talk about those. They're very hip in integration, so messaging and Kafka. Let's super quickly talk about messaging. Does anybody use a message bus? I can't do show of hands, but normally there are 30%, 20 to 30% who has no problems. One hand normally, or sometimes two, brave people. Because the problem is, if you use messaging, I have a slide on that, you might want to charge the credit card. No, it's no longer a REST call, but you might send a message to a message bus that's picked up by the credit service. If now something fails, messaging has built-in retry capabilities. That's great, right? So the infrastructure can do the retry. The thing is that when that retries are expired, normally what happens, the message is sent to a so-called dead letter queue. I can't process it. And surprisingly enough, the tooling is really bad for managing that. So I see a lot of struggles with that still, right? So if I use messaging, I find it important to also think about these kind of timing things. So for example, I could still have that and then wait for the response and monitor the response not coming back. And then you have like a very different way of monitoring things. But okay, that was the messaging part, the not so important thing here. I wanted to talk about Kafka in 4 minutes. And this is the whole idea of, if I say Kafka is known as an event bus. And the whole idea is then normally to build event-driven systems. So for example, now payment is embedded in a couple of other things to do order fulfillment. So if all these kind of services might emit events, and then the good thing is that I can build services that just react to those events, like a notification service. Nobody has to know when notifications are sent. They just produce certain domain events. Great. But what happens is that a lot of people now also use these event-driven integrations for what I call peer-to-peer event chains. So you could implement an overall process, an overall flow by that. Like, hey, there was an order placed, payment picks it up, retrieves the payment, says, hey, payment was received. Eventually, okay, then we have to get the goods from stock and so on and so forth. So you implement a certain process by doing certain event subscriptions, basically. And I find that a very, very, very dangerous thing, actually. And I saw problems with that at a lot of customers because for two reasons. The one is you don't see the overall flow anymore. And if you have not 4, but 20, 40, whatever services, it's pretty hard to understand what's going on. And it's also really, really hard to change it, to adjust it, saying, okay, we want to do something before that happens. And we see more and more changes, even of core business processes because of new technologies, of new possibilities, of new customer expectations, and so on and so forth. Right. So I find that very risky, and a lot of people are also talking about that quite openly now. My favorite example here is Phil Calzado. He worked at Meetup back then. We are suffering from pinball machine architecture. He called it the event-driven thing. Like, we have an event, it bounces through the system, and we have no idea what just happened. Martin Fowler also blogged about that. Let's not go into that. So, and it goes into the same direction. I think in some integration scenarios, it's more advisable to, I don't define it here properly, but to have more a command style or request response style of interaction where you have, for example, the order requesting the payment, and then you have the overall flow also visible and controllable and manageable. At the same time, that gets long running. That's pretty cool. And then you might have a lot of those services that have this integration logic, and it gets quite blurry. As you can see, the charging of the credit card was a very, let's say, low-tech use case where we started with, but it might be embedded in a bigger flow that's all logic we need for payment. And it's always then, integration logic that sits within the payment server. Okay. If you want to know more in code, same example, there's also some Kafka example there. I know that was a lot in a short time in the morning. Maybe it was not morning for you. That's probably would be easier then. So we get more and more complex systems. We have more and more components to integrate basically by the day. Right. Therefore, you have to know some patterns, like retrying is super important. Idempotency is super, super, super important. Being aware of these challenges to design good APIs, but then also have long-running capabilities to think about, like, okay, can the right service solve their problem on its own? And then probably it gets long-running, probably integration logic gets a bit more complicated, but that's fine. It gives you a much better overall architecture. Yeah, that's all I have.